Hello, this video is to help you understand heat pumps and refrigerators for your Engineering Thermodynamics 1 course. I will be explaining what a heat pump/refrigerator is, how they work, and how you can measure the efficiency or effectiveness of each device. So first off, what even is a heat pump? Well, if you feel like you know, maybe pause the video and try and write down your own definition real quick. But if you don't know, that's perfectly fine too. I would describe a heat pump as a device that moves heat from a place of low thermal energy to a place of high thermal energy. These devices are everywhere and virtually every building has one. So if it is currently colder outside than it is inside, then there is right now a heat pump bringing heat into the room that you are in. Now you should also note for your class that a heat pump is a working device. So when you are doing any sort of first law analysis on one, there is going to be some measurable work in. So the next big question is, how does a heat pump actually work? Well, we know that heat naturally moves from a place of high heat to low heat. So if I were to take a room and heat up one side of it, that heat would eventually migrate to the other side of the room. And if I came back after a while, the whole room would be one temperature. So why is it that a heat pump seems to generate the opposite effect? Well, in reality, a heat pump is not just one device, but it is a series of devices that uses a working fluid, usually called a refrigerant, to create this effect. So let's look at how that works. Okay, so here's the general layout for our heat pump. It is made up of 4 components, which I have not listed yet. That's because I'd like for you to take a second and pause the video and see if you can name each component. Okay, so we have the evaporator, the compressor, the condenser, and the expansion valve. And each of these either does something to our working fluid, or it allows for a heat exchange between the working fluid and the surroundings, and we'll go over those in just a bit. Speaking of the working fluid, I mentioned earlier that heat pumps use something called a refrigerant, and that is just a chemical that has a very low boiling point. So throughout this process, the refrigerant is switching between being a liquid and a gas. Now let's look at the heat pump as a whole. So I mentioned earlier as well that a heat pump is a working device, so you do have some work going into the compressor. And then I have marked a low temperature zone on the bottom and a high temperature zone on the top. So the low temperature zone will transfer thermal energy into the evaporator, into the working fluid within the evaporator, I should say. Then that working fluid moves through the heat pump up to the condenser, where it transfers thermal energy into the high temperature zone. Now let's look at what each component does on its own. Now you should note that in this class you don't need to know exactly how each component works, you just need to know what it does to the system. So we'll start with the evaporator. The evaporator simply exposes the working fluid to the low temperature zone. Now, at this point, the fluid is very cold. It's colder than the low temperature zone. So because of that, heat flows from the low temperature zone into the fluid. That fluid is then carried into the compressor. The compressor takes work and it uses that work to increase the pressure of the fluid, which in turn increases the temperature of it. So you can see that the fluid coming out of the compressor is very, very hot. That fluid flows into the condenser. The condenser does essentially the same thing as the evaporator, except now the fluid is hotter than its surroundings, even though it's on the high temp side. So thermal energy flows out of the fluid and into the high temperature zone. And then last, the fluid flows through the expansion valve. The expansion valve is essentially the opposite of the compressor. It lowers the flow, so it lowers the pressure and the temperature, so that after it is done, it flows back into the evaporator nice and cold and ready to pick up more heat. So that's the basic idea of how a heat pump works. Now you might be asking yourself, what's the difference between a heat pump and a refrigerator? Well, they're actually the same device, but they just serve different objectives. Let's look at each one. So a heat pump brings heat from the cold outside environment and brings it into a warm controlled environment, whereas a refrigerator brings heat from a cold controlled environment to the warm surroundings outside of it. So they work in essentially the same manner, it's just which environment is controlled is different for each device. Now before we move on, I want to draw your attention to the diagram. Either one works, I just want to look at the flow of energy shown within each one. So first we have the work net in, that is just the work energy flowing into the compressor. We have QL, which is the symbol for the thermal energy leaving the cold space and going into the heat pump. And then we have QH, which is the thermal energy leaving the heat pump and going into the warm space. Okay, the last thing we'll talk about is the coefficient of performance, or the COP. The COP is just a measure of the efficiency of a heat pump or refrigerator. And it works very similarly to other efficiencies you've seen. Its basic formula is the desired output over the required input, which can also be stated as QH over work in. Now, for a refrigerator or a heat pump, there is a different COP. They're very similar, but the formula changes a little bit. So for a heat pump, the COP is equal to the QH over QH minus QL. For a refrigerator, it's almost the same thing, except it is QL on top and still QH over QL on the bottom. And if you ever want to relate the two of them, the COP for a heat pump should be equal to the COP for a refrigerator plus 1. And that's everything for this video. I hope it has helped, and thank you for watching.